Okay, hey, my name is James Andrew Whitlock, and today I'll be doing the electron projection problem. And start off the question asked is an electron is projected at an angle of 30.2 degrees above the horizontal at a speed of 8.12 times 10 to the 5th meters per second in a region where the electric field is E equals 393 J N over C. Neglecting the effects of gravity, calculate the time it takes the electron to return to its initial height. First of all, I'm going to say I went ahead and worked out all the problems to all the answers to all this question because I tried recording a video and while working it out and it just took too long. So this is what we're going to do. Plus, it's hard to keep up with me writing and aiming at the thing. So first of all, we'll start off with F equals QE. This is the first equation we need. So Q is the charge of the electron, and then E equals what was given, which is 393. And the C's are going to cancel out. So it's just going to be the, basically you times these two numbers and it'll be negative 6.2 times 10 to the negative 17 N. And when we do this, we're going to use this formula, A equals F net over M, which is the mass of the electron proton thing. So we just solve for F net and then divide it by 9.11 times 10 to the negative 31 kg, and that's going to give us this number, 6.9 times 10, or 9.02 times 10 to the 13 meters per second. And moving on, we're going to use this equation since it's projectile motion, and this is going to be a kinematics equation, and it's basically the change in height and relative to change in time with a little bit different notation with velocity and acceleration. And basically we can assume change in y equals 0. So we can plug that in, then basically solve for change in t since that's what we're looking for. And that's gonna basically end up with this formula right here. Change in t equals negative 2 VI y over 8y. And we just solved for AY, so we're gonna plug it in right there. We solved it earlier. Make it a little more legible. And now, but the problem is it won't focus, okay. Negative 2 VIY, we need to solve for VIY. And basically you can do that by doing VI sine theta, so the vertical part. So, and we were given earlier 8.12 times 10 to the 5th meters per second. And sine of the angle given, which is 30.2, equals 4.08 times 10 to the 5th. And plugging all these numbers in gives you 1.18 times 10 to the negative 8 seconds. And that's the answer to part A. So part B is to calculate the maximum height that it reaches. And this right here, this number was solved earlier, just like it was in the example for me. So we're gonna hold on to that for a little bit, but we're gonna use another kinematics equation, and then find out. You're gonna break it down into the change in height. So that's gonna equal the negative VI y squared over 2AY. And then basically, we already solved for all these numbers. You got them earlier. You can just plug them in again right here. So 4.08 times 10 to the 5th raised to over 2 times 6.9 times 10 to the 13. Negative 6.9, by the way. And so there was a negative in the front. That's going to give you the maximum height is 1.12 times 10 to the negative 3 meters. And the last part is we're going to solve for the horizontal displacement that it reaches when the maximum height. So you can use a horizontal acceleration. That number I told you earlier is going to come into play right here. It's going to be the change in t, and then the VI we already know from earlier is 8.212 times 10 to the 5th. And then this time we're going to do cosine the angle, which is 30.2. And that's going to end up equaling 4.14 times 10. That's supposed to be 10 to the negative 3 meters. And that is all for this. I'm sorry I couldn't work it out. It took 5 minutes just to explain, try to give a good explanation. So thank you for your time, and goodbye.